Now we're going to look at graphing the secant and cosecant functions, which are the reciprocals of the sine and cosine graphs. So no matter which graph you're asked to draw, the secant or the cosecant one, you're going to start off by very lightly sketching the sine curve for a cosecant function or the cosine curve for a secant function. Now you do need to make this a very light sketch. Just do a dotted line or maybe even just draw the dots for the high points, the midpoints, and the low points, because this portion of the graph is not our final answer. We're just going to use it to guide the shape of our final answer, which will be the secant and the cosecant graph. So the reason we sketch in the sine and cosine curves is because we will have asymptotes wherever that sketch touches the x-axis, the zeros of the sketch. And the reason that happens is because since the reciprocal function is taking the y-coordinates and flipping them upside down, whenever the y-coordinate of sine or cosine is 0, taking the reciprocal of 0 puts 0 in the bottom of the fraction. So that creates undefined values, which are asymptotes on the graph. And then the other thing that's going to happen is wherever we have a maximum or a minimum from the sine or cosine curve, we're going to draw a parabola that just barely touches those maximums and minimums and then goes in the opposite directions away from the graph. So you'll see that I've already filled in my scale for drawing the graph on this one. And since we're doing a secant of x function, I'm going to start with a light sketch of cosine. So with my scale marking off the horizontal tick marks as pi over 2 for every 2 lines, then I have pi over 2, pi, 3 pi over 2, and 2 pi. And vertically, I've marked that it's 4 tick marks equals 1. So for the cosine graph, remember that it starts at the point 0, 1. And then at pi over 2, it hits 0. And then pi, it hits -1. And then back to 0, back to 1. And then just keep extending that pattern in both directions. So on this side as well, in the negative angles, I can go back to 0, back to -1, to 0 again, to 1, and back to 0. Now, again, if you want to kind of lightly draw in some more dotted lines to help you see the shape of the sine and the cosine graph, you can, but do keep this very light and dotted. This is not our final answer. It's just helping guide the shape of the final answer. So now I have sketched in the cosine curve based on what we did on another video. Step 2, now we're going to make an asymptote wherever the sine or cosine curve touches the x-axis, the zeros of the function. So I see lots of these intercepts here. There's one here. Here's another place where the sketch touched the x-axis, and another one. So you should have a whole bunch of asymptotes all the way through the function. And that's because the reciprocal of 0 is undefined. And so the last step is going to be to actually draw the secant and cosecant curve part. These are an interesting looking shape. It's basically just a pair of parabolas, one parabola going up and one parabola going down for a single period of the function. So whenever you see a maximum on the graph, like right here, this is a high point for cosine, you draw a dot at that point and then a parabola going up. And the reason that happens is because if the y value is 1, when you take the reciprocal of 1, you still get 1. So when cosine is 1, secant is 1 as well. But as you get to some of these numbers really close to the asymptote, you end up with really small fractions, like 1 over a million. Well, if you take the reciprocal of 1 over a million, you end up with a million over 1. So the reciprocal graph ends up super tall whenever the cosine graph is very small. So that's what causes this kind of shape. And then the same thing happens for the minimum values. Here's a low point on the curve. So I draw a dot at -1, and then a parabola going in the opposite direction away from the sine and cosine curve. So that's one period of the graph. It has both a parabola up and a parabola down. And then I just duplicate that for all of the other maximums and minimums that I see on my graph. So here's another one going up. Here's another one going down. That's another period. And then here's another one going up. And that's it for our function. So you do need to make sure that it's clear you're only including these red marks that I've made here, these red parabolas, as the actual graph of secant and cosecant. Either use different colors or make sure you do very dotted lines for the other information. It's nice to have the asymptotes drawn in, but the most important thing is recognizing the secant and cosecant graph is just these alternating parabolas. Now we're going to do a function with some transformations being applied to it. Now I've started to mark off my scale, but I did want to help you out with whenever there's a number being multiplied or divided by the x value, because that usually dictates how I set up my horizontal scale, my x tick marks. So whenever you have a number either underneath x or being multiplied by x, what I recommend is that you find the period of the function. And remember, the period comes from 2 pi divided by b, and b in this case is 1/2. But instead of dividing by a fraction, it's easier to use your keep change flip rules. So instead, think of it as 2 pi times 2. So I'm getting a period of 4 pi. And then what I do with the period is I take that number and I divide it by 4. I always like to break the period into 4 pieces because there are 4 pieces to completing one full cycle of the graph. So if you break it into 4 parts, that'll make it easier to measure off the high points, midpoints, and low points of the sine and cosine graphs. So take your period and divide it by 4. And in this case, I'm getting pi. So that's what I'm going to use for my horizontal tick marks. Each one is going to be a length of pi. So starting from the origin, this would be 1 pi. And then this would be 2 pi, 3 pi, 4 pi, or going in the direction negative pi, negative 2 pi, negative 3 pi, negative 4 pi. So that's a helpful way to set up your scale, and that way it'll take care of any of the horizontal stretching and compressing. So now my scale is set. Horizontally, each tick mark is pi. Vertically, I'm doing each tick mark as 1, which is a little different than the last one, just because I saw this graph was getting doubled in height, so I didn't want to go too far off the grid. So now we need to lightly sketch in our sine graph because this is cosecant. Sine and cosecant are reciprocals. So for the sine graph, usually I start at the point 0, 0, but don't forget that this one is going to be doubled in height. I've already taken care of the horizontal stretching and shrinking by changing my horizontal scale, but I do still need to take into account the doubling height. So my first point's at 0, 0, and then usually the next tick mark hits at a height of 1, but now it's going to hit at a height of 2 instead. And then back to 0, down to what would have been -1, but now is going to be -2, back to 0, and then just keep extending that pattern throughout the graph. So on this side, it continues to go down, back to the middle, back to the top, back to the middle, and back to the bottom. Second step, wherever that sine curve that you sketch in, wherever it touches the x-axis, we need to make a vertical asymptote. So I see one location here. I'm just going to draw a dotted line for my asymptote. Another one right here. Another one going right through the origin, so kind of harder to see that one. Another one over here. And another one over here. Last step, wherever you see a minimum, draw a parabola going down. Now half of this parabola has kind of gone off the grid, so I'm not going to show that left-hand side of the parabola going down. But here's a maximum, so that one's going to go up. Here's another one going down. So they should be alternating. Another one going up. And then don't forget that only the purple lines that I'm drawing right here are actually my final answer. And again, this one's getting kind of cut in half just from where my grid landed, but there technically is a piece going up on that side as well. So we took care of the doubling height, and by changing our scale, we took care of the horizontal stretching in this case. So the graph usually has a period of 2 pi, but this one actually has a period of 4 pi. So if you measure the horizontal distance, how long does it take this graph to repeat a cycle? It's actually a length of 1, 2, 3, 4 pi, and then it starts itself over again with another vertical piece. So all of the information matches what we have in the equation. And that's it for the notes. Thanks, guys.